Hello viewers, welcome back to my channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. Also, I have created bunch of playlists to cover various categories of the problems such as breadth first search, depth first search, dynamic programming, and so on. And also you will find several playlists that I have created to cover various data structures such as trees, graphs, linked lists, tags, queues, and so on. You can check them out in the playlist section. I have uploaded the code for this problem to the GitHub repository. You can get the link from the description below this video. Let's jump into today's problem. Course schedule. There are total of num courses you have to take labeled from 0 to num courses minus 1. So let's say there are n courses, they are labeled from 0 to n minus 1. Okay, so some courses may have prerequisites. For example, to take course 0, you have to take course 1, which is expressed as pair 0 to 1. So that means in order to take course 0, you need to take course 1. So that is the order of the courses will become 1 and 0. So you have to take course 1 first and then only you can take course 0. That's what the prerequisite means, right? So prerequisite, even though the array given here like that, right? But what the order of courses becomes, so it will be 1 first you need to take and then only you can take 0, right? So that's what it is. So you have to take course 0, but in order to take course 0, you need to take course 1 first, right? So the order becomes 1 and 0, right? So that's what it is. We need to understand in that way, even though the pair given is 0, 1, right? But the order of the courses in which you have to take will become the opposite, right? So that's the key here in order to understand, right? So keep that in mind. Even though the pair given is 0 to 1, just understand that the order in which you have to complete is 1, 0, the reverse, right? So that's the key here, okay? And now, given the total number of courses and a list of prerequisite pairs, is it possible for you to finish all courses, right? So basically we are given with the prerequisites. There are n courses numbered from 0 to n minus 1 and you have given with the prerequisites. So basically things are like this, right? 0, 1, 2, 2, 3, 4, 5, something like that, and you need to come up whether you can finish all of those courses without any conflict. If you are able to finish all those courses, return true, otherwise return false, right? So let's go ahead and try to understand with an example, right? So in the example 1, the number of courses is 2 and prerequisites is just 1 prerequisite. So 1, 0. That means in order to take course 1, right, you need to finish 0, right? In order to take course 1, you need to finish 0. So that means what is the order becomes? So you need to do 0 first, right? And then do 1, right? In this case, we are able to finish all the courses, return true, right? Let's look at the example 1, right? So you have, in order to take 1, you need to finish the course 0, it said. Okay, now I want to go take course 0. But in order to take course 0, I need to finish 1. That's what it said, right? So this is like a interdependency. In order to finish 0, you need to finish 1. In order to finish 1, you need to finish 0. So that means there is an interdependency, which you can think like a cycle, right? So there is a cycle between 0 and 1. That means you won't be able to finish the courses, the 2 courses, right? So then in that case you are returning false. So basically this will be imagined as a problem of graph where each course will be a node in the graph and each prerequisite will be a edge in the graph. So the only thing is the graph edges are, the prerequisites are directed edges, right? So when you say 0, 1, right? So you need to take a course 1 before taking course 0. That means, right? So 1 should come first and then only 2. That means there is an edge from 1 to 0, right? So imagine like that. So basically you have courses as nodes in the graph and edges are the prerequisites. So the only differentiation that we need to figure out here is how to represent the edge here, right? So the prerequisite, even though it says take course 0, you have to take course 1, right? That means the edge is reversed here. So the edge is coming from 1 to 0. That means you can finish 1 only after you can finish 0, right? So that's the edge we will have in our minds. Okay, so now let's go and try to understand these examples, right? This one we talked. So 0 to n minus 1 when n is equal to 2, 0, 1. This is example 2. I have represented here in a graphical format here with the text editor basically. So there is an edge from 0 to 1 and there is an edge from 1 to 0 also, because you have the interdependency, right? So you are able to see there is kind of cycle forming. So in this case the cycle is forming, right? That's why you will say, okay, since it is a cycle formed, you won't be able to complete all the courses. So to go forward, I will be operating with the A and B's, okay, with the A and B's. So A, B, A, B, right? So there is a edge called AB and you would start from A to B. So that is a edge that we are, I mean, the common language that we use to represent. But in this case, what we are saying is the edge is not actually this. This is not the edge. So edge is B to A, right? So means A can be finished only after B. So A has prerequisite, B doesn't have a prerequisite, right? So B doesn't have a prerequisite, but A has a prerequisite, right? So A has a incoming edge, right? B doesn't have a incoming edge, right? So just like we represented 0, 1 as 1, 0, right? So 0 has an incoming edge, but 1 doesn't have any incoming edge, right? So there is no prerequisite to finish 1, right? Like that. So going forward, so what we are going to do is we will be doing the topological sort in order to solve this problem, right? So the first step in topological sort is we need to find out the nodes in the graph where there are no incoming edges, right? So there are no incoming edges. So to translate that to our problem, right, since we are dealing with the prerequisite courses, right? So now to translate that into our problem, right, you need to identify courses where there are no prerequisites, right? So 1, 0, that means 1 has a prerequisite of 0, but does 0 has any prerequisite? Nope, right? 0 doesn't have any prerequisite. So we are looking for that kind of courses. That's what is identifying the courses with no prerequisite, right? So transforming this back, right? So let me take, we actually don't need all this. So 1, 0 is the prerequisites. So in order to complete 1, you need to take 0. But in order to complete 0, do you have any prerequisite? No. So that's what. So identify the course. Just for the going through the algorithm and trying to solve the example 1, right? I am going to keep track, okay, in a way. So now identify course with prerequisites. What is the course? 0, right? So course now with no prerequisites is 0. We identified. So course we are taking it as node and prerequisite an edge, right? So if B to A is there, if BA is a prerequisite array contents, right, then we will say the edge is A to B. Similar to what we said, right? It's same. You have a B to A, that means A to B is an edge. So courses with no prerequisites, I am putting it as A. So A doesn't have a prerequisite, B has a prerequisite, right? So now just like in the example 1 we identified course 0, right? Now I am saying courses with no prerequisites is A for this particular example. And I will have the order of the courses in which we are going to finish. Initially, since we are getting started, it will be empty array, right? So now courses with no prerequisites is A, only one course, and order of courses will be empty. Now what we are going to do is in the second step. So the first step is we identify that information, right? And second step with the algorithm of topological sorting is you have to take out one element or one node from course with no prerequisite, right? So take out one, that since it has only one right now, I am just directly saying take out A, right? We took out A. So after taking out A, courses with prerequisites will be empty, right? So now we need to find all such edges where A to something. I put B here because B is there here, but anything B star I will say, right? Anything A to any number, right? So A to all nodes, right? You need to all other nodes. Do you have any such edges? So that is the next step. So if there is any such kind of edges, what we are going to do is remove that edge from the graph first. So now since we are going with only one thing, there is only one edge. So you remove that edge from the graph, assuming this is the graph, right? So let's say that is a graph, you will just knock that off and those nodes are existing. So that's what I meant, remove that edge from the graph and check if there are no other incoming edges. So in this case, does B have any other incoming edges? Remember, we already removed A to B edge from the graph and check if B has any other incoming edges. No, right? So B doesn't have any other incoming edges. If B doesn't have any other incoming edges, what you are going to do is add B to courses with no prerequisites. That means B doesn't have any prerequisites anymore, right? So add that to B. Sorry, add B to course with no prerequisites. We added that to B. So now course with prerequisites has one more element in it. So while doing that, that means you are able to finish course A, right? So add course A to the order of courses. That's what we are doing. Add A to order of courses. Order of courses, initially when we started it was empty, now we added A. Next, we have to perform the step 2 as long as course with no prerequisites is non-empty, right? So now what is the content of course with no prerequisites? This one, B. So just for the illustration, right, I just have 2.1. So 2.1 is essentially recursion of or one more time, basically not actually recursion. So repeat of step 2, okay, repeat of step 2. So in the step 2 what we are saying is, in previously we just had 1 and I said take out A, right? Even now also we have just 1, now I am saying take out B, and course with no prerequisites is empty now, and get edges such that B to all other nodes, anything basically. So do we have anything like that, B to any other edges? No, in this particular graph there are no edges. So there are no edges, right? We don't need to process further. What we are going to do is order of courses, you add this B. So now B is added to the order of courses. What is the order of the courses now becomes, it was only A, now we added B. So the order of courses is AB, right? So that's what it is. So we exit at the second step. Now in order to say true or false, that's what we are going to return, right? Is it possible for you to finish all the courses? We have to check whether order of the courses, right, length of the order of the courses is equal to n or not. Length of order of courses is equal to n or not. What is n? N is the number of courses, right? So we said n is the number of courses. If it is, then return true, otherwise return false. That's it. So topological sorting has 2 steps, right? You identify the courses with no prerequisites, right? If there are no courses with no prerequisites, then we will return saying, okay, all the courses have prerequisites, I cannot really do anything, right? If all courses have prerequisites, you can't really do anything. That means there must be cycle compulsory, right? In that case, you don't have to do all these step 1 and step 2 processing at all. But if you find at least one course without prerequisites, right, then you proceed further for the topological sorting, right? Let me write a note here. If there are no courses, if there are no such courses, right, return false then and there. You don't have to do step 2 or whatsoever, right? But if there are, then you go to step 2. You take out a course with the course without no prerequisites and then perform this operation. So just want to remind you, 2.1 is just a repeat of step 2. That's it. So finally, when you come out, the length of order of the courses should be equal to the n, where n is the number of courses given. As long as that satisfies, you're good. Otherwise, return false. That's it. So now let's go ahead and jump into the code, right? It exactly follows these 2 steps, right? So there are things that we need to take care in order to represent the graph, right? So how we are able to find the incoming edges, how the graph will be labeled, and all those things we will take care in the code. Just to give you a heads up, right? So I am going to call n as number of courses like what we followed till now. M is the number of prerequisites, okay? M is the number of prerequisites, whatever the length of the prerequisite array. And courses, it will have all the courses with no prerequisites. That's what this one is, course with no prerequisites. So we will initialize all the courses to start with in the courses, but while we go through the prerequisites array, we will knock them off, whatever the courses which have prerequisites. So finally, what we are left with in the courses is courses without any prerequisites, and we will have order of courses where we are keeping track of this, right? So that will be another array. So we will have to have a placeholder to maintain the graph, right? To maintain the graph, there must be a placeholder for the incoming edges and outgoing edges. We will do that with a set of maps, right? Let's go jump into the code, right? So it's a simple straightforward code after you understood the topological sort algorithm. So now you have number of courses n, m is the prerequisites length, right? And you have a hash set of courses. So imagine this is courses without prerequisites. Maybe I should have named like that, but yeah, prerequisites, without prerequisites. And you have a graph. This is a full graph where you will say what are the outgoing edges for a given node, and for this one, what are the incoming edges for a given node. I have 2 maps. So graph is what are the outgoing edges, and incoming is what are the incoming edges, right? So now I will go through the courses and initialize the hash set and the graph and incoming edges. Basically, this is outgoing edges and incoming edges. I am initializing this. So basically, so now I will go through the prerequisites array. This is where we are forming the edges, right? So number of courses we just have only as nodes. So at here we are actually forming the graph. So you have a course and you have prerequisites. The first 0th element is a course and first element is a prerequisite. That's what we learned, right? 0. In order to take 0, you need to finish 1. So 1 is the prerequisite, right? That's what I am calling. So courses, you remove the prerequisites, whatever it is there. So that means 1 has a prerequisite, 0. So you remove that, right? So we said courses will keep track of all the courses without any prerequisites only. And you add these incoming and outgoing edges into the graph and incoming. So now the courses hash set will have only the courses which doesn't have prerequisite courses, right? That's what our definition is. So that is the step 1, basically. Step 1 of topological, step 1, right? This is what we are verifying here. So although this is a step 1, right? We can go back and say this is a step 1, right? So now courses will have only the courses which doesn't have prerequisites. Let's say if the courses.count is 0, that means you don't have any courses without any prerequisites, just return false, like we noted down, right? So if there are no such courses, return false then and there, like that. So you return here, you don't have to proceed further. But what if there are at least one courses without any prerequisite? You proceed further. So like we said, we have order of courses, that is a list I am creating, and going further, while courses count is greater than 0, we proceed. This is our step 2, right? Step 2. So where we said step 2 and 2.1, this is essentially step 2, that's what we said, right? So we will repeat this thing until the courses.count is becomes 0. So you take first course, you don't have to take first course, you can take anything, but for the simplicity I just took the first course from the courses and remove that from the courses, because you don't want to reprocess that again and again, right? You remove it from that and then add it to the order of the courses. You add it and then check if there are any edges starting from that node to other node, right? If you have any edges, you process those edges. That's what we said, right? In the second step, find all such edges, A to anything, right? A to anything. So that is what is represented in our graph, right? In the graph, just get all the edges starting from that node. If you have any edges, process them. If you don't have any edges, you're good. You come out of this loop and just check whether the order of courses is equal to n or not, as long as courses.count becomes 0. But if there are any edges, right, then you need to remove those edges from the graph, right? Remove those edges from graph, right? This is our second step, right? Remove those. So these two will be removing, and after removing, if the incoming of that edge becomes 0, you add that particular course back into courses, right? So this is E, not A, the current course, right? Current course is already added to the order of courses, but this is an outgoing course, right? So you add that and do further processing. So that is how we are able to do the step repeatedly through this while loop, right? So at the end, we will be checking if the order of courses, the count of order of courses is equal to n or not. If so, we will return true, otherwise we will return false. That means we are not able to complete all the courses. So if you have any further questions, please post them in the comment section. I will get back to you as soon as I can. Now let's go look at the time and space complexity, right? Time, space, right? What is the time complexity? So we are going through the number of what is this, courses, right? N once, and number of edges, that is prerequisites, once. So what does it become? Order of n, first one, order of n plus order of m, right? Plus we have this while loop, right? So if there are any courses, we are visiting each course exactly once, right, in this while loop. As long as there is only visited once, since we are removing all those edges gradually, right? So you won't be visiting a single node more than once. So how many nodes are there? Again, the nodes means courses. Again, order of n, right? So totally the time complexity will be order of 2n plus m. So since we are going to remove all the constants from the big O notation complexity, it will be order of m plus n. That is the time complexity. What is the space complexity? Let's go ahead and look at it. Are we using any extra space? Oh yeah, why not? We are using extra space. This is courses, right? So how many courses are there? Order of n, right? Plus, and this is a outgoing and incoming edge graph, right? So how many are there here? The edges per se, edges are nothing but prerequisites. That means order of m, right? right, even though you are representing 2 times, right. So, that will become order of 2m, right. So, apart from that, are we using any more space? Yes, we are using order of courses, right. How many courses are there? N. So, order of courses will have n again. So, that means the total will be 2n. So, the space will be order of 2n plus 2m, which will be order of m plus n courses, right. So, basically the space complexity is also order of m plus n and time complexity is also order of m plus n. So, if you have any further questions, please post them in the comment section below this video. I will get back to you as soon as I can. I have posted the code to the GitHub repository to the link specified below. You will find 2 languages, C# and Java. So, the links can be found in the description below this video. If you haven't subscribed to my channel yet, please go ahead and subscribe and share among your friends as much as you can. Please click on the bell icon so that you will be notified about all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.